Welcome, students. Today we're going to talk about the quadratic formula, which is the capstone to this course. It's kind of the grand finale of the course. It's the last new topic that we're going to cover, and it is one additional way that we can solve quadratic equations. So we have learned a few different ways of solving quadratic equations. We have used factoring, along with the zero factor property. We used the square root property. We learned how to complete the square, completing the square, which we used in tandem with the square root property. And today we're going to talk about the quadratic formula. Now, you may have seen the quadratic formula before. I'm going to give you the formula first, and then we're going to use the formula to go through a few examples. In the other video below, you can actually see I will derive the quadratic formula. I will show you where it's come from, how to develop it. Effectively, it comes from completing the square. But in this video, I'm just going to give it to you, and then we are going to go through some examples. So here is the quadratic formula. It says the following: the solutions to the equation ax squared plus bx plus c equals 0, with a not equal to 0, are given by x equals, we've got a big fraction, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is a formula that we can use to figure out what the solutions are to a quadratic equation by taking the coefficients a, b, and c and plugging them in to this formula and then evaluating it. Now, the only reason it says a is not equal to 0 is if a is 0, then we have no x squareds and it's just a linear equation. So obviously, in that situation, we would just use the regular methods for solving equations, adding and subtracting the same thing from both sides, multiplying and dividing both sides by the same non-zero number, etc., etc. This formula, though, is going to work whenever we have a quadratic equation. Now, if you want to see where this comes from, watch the video below where I derive the quadratic formula. I think it's a good video to watch. But right now, I want us to focus on actually using this to solve quadratic equations. So let's go and do an example. Let's solve x squared minus 5x plus 2 equals 0. Now, first we have to identify what a, b, and c are so that we can plug them in. A is the coefficient on the x squared. So in this case, a is 1. It's that invisible 1. B is the coefficient on the x term. In this case, it's -5. And c is that constant term, which is 2. Now we're going to plug these into the quadratic formula and then evaluate. So we have x equals, and we start off with the opposite of b. Well, if b is -5, then the opposite of -5 becomes +5. Those negatives cancel. Then we have plus or minus the square root of b squared. Well, in this case, -5 squared is 25, minus 4 times a, which is 1, times c, which is 2, all over 2 times a, which is 1. Once we've plugged things in, we can go and evaluate. So we've got 5 plus or minus. Let's look underneath the square root. We've got 25 minus this product 4 times 1 times 2. Well, 4 times 1 times 2 is 8, so that becomes 25 minus 8 over 2 times 1 is 2. And then 25 minus 8 is 17. So we end up with a 17 inside the radical. Now 17 is not a perfect square, and it doesn't contain any perfect square factors, so there's nothing we can really do here to simplify this, and none of these are going to divide by 2, so we can leave our answer like that. This is fine for an answer. You could also split it up into 2 fractions, 5/2 plus or minus the square root of 17 over 2. Either one of these is acceptable as an answer. It's generally a little bit better to split them up because sometimes we will have something that we can reduce. And in that case, we always want to reduce it. But in this case, either one of these works as an answer. Let's take a look at another one. And then if you want to look at more examples, which I encourage you to do so because all of these examples are going to be just a little bit different, you can look at the other videos linked below. Let's do one more though. Let's solve x squared plus 3x minus 10 equals 0. Again, we need to identify a, b, and c. A is 1, b is 3, and c is negative 10. Now let's plug them into the formula. We start off with the opposite of b. Since b is 3, the opposite of 3 is negative 3. Plus or minus the square root of b squared. In this case, that's 3 squared, which is 9, minus 4 times a, which is 1, times c, which is negative 10, all over 2 times a, 2 times 1. Good. Now we can look underneath that radical. I want to point something out here. We're going to start off with 9, but then we are subtracting something that's being multiplied by a negative. Those are going to cancel out, and this is going to turn into an addition. And then we've got 4 times 1 times 10, which gives us 40. And in the denominator, 2 times 1 is 2. So underneath that radical, we now have 9 plus 40, which we know is 49. So we can rewrite that as 49. So we've got negative 3 plus or minus the square root of 49 over 2. Now this is different from the last problem because now we have a perfect square underneath the radical and we can evaluate that. This becomes negative 3 plus or minus 7 over 2. And now we're going to want to look at these two solutions separately because we can actually take negative 3 plus 7 and negative 3 minus 7 and divide those by 2, and then we'll get simpler answers. So we've got negative 3 plus 7 over 2, or x can be negative 3 minus 7 over 2. Now negative 3 plus 7 is 4, so we've got 4 over 2, which is 2. And then over here, negative 3 minus 7 is negative 10, and negative 10 divided by 2 is negative 5. So we end up here with two solutions, x equals 2, or x equals negative 5. Now, one last thing before I ask you to look at the other videos of examples. If we look at the original equation here, this is actually something that could be factored. And if we solve this by factoring, it's going to be a lot less work than going through and doing all these steps. So today, we're going to get practice just using the quadratic formula. But after this, when you're allowed to use any method that you'd like, I would recommend using factoring whenever you've got a polynomial that can be factored, and saving the quadratic formula for a situation where factoring doesn't work.